All right, let's go ahead and do two problems that have quadratics and imaginary complex roots. You can look at them on the graph and determine that they have imaginary complex just by determining that it does not cross the x-axis. You'll notice that parabola does not cross the x-axis. That tells us we have imaginary complex roots. Now, in order to do this, first thing we're going to do is look at the quadratic and see how simple it is. You'll notice that there is no middle term or no linear term. And because there's no linear term, the mathematics is actually easy behind this one. We just take the addition of 1 and we subtract 1 over to the other side. We're left with x squared equals to -1. And then we take the square root. So we would say x equals to the square root of -1. And of course, when we take the square root, you really need to remember that there is a positive and a negative answer. So let's go to Desmos and just type in the square root of -1. So SQRT, -1, boom, what you gonna get? You get undefined. That's because you can't take the square root of a negative. And that's where we have imaginary numbers, complex numbers. And what this is telling us by saying it's undefined in this case is just simple. It's saying, hey guys, it's not crossing the x-axis. So we come back over here, and what I'm going to do is I'm going to change my answer. One thing we need to pay attention to is I is just simply the square root of a -1, or just square root of a negative. So what I say in this case is x equals to plus or minus I. Now that's assuming that that is a linear term. So let's go to the second one. Notice that there is no linear term again. We subtract the 25. We subtract the 25. X squared comes out and we get -25. At that point, we go ahead and take the square root. The square and the square root cancel. X comes out and we get the square root of -25. Well, I know that the square root of a negative is going to give me I. Okay, and then I know the square root of 25. I can go type that into Desmos, but we should know that the square root of 25 is 5. So this is plus or minus 5i. Okay, and this is if we have no linear term in there. But when we go to C, you're going to notice that there is a linear term. So this becomes a little bit more complicated. What I do is I go to vertex form. Okay, and that's where I'm going to start. I'm going to go to Desmos and I'm going to type in the original problem, and that is x squared minus 4x plus 5. So let's type that in, x squared minus 4x plus 5, and I'm going to find the vertex, which is 2, 1. Once I've got that, I'm going to put it in vertex form. So I'm going to take this, I'm going to change it to vertex form, which is x minus 2 plus 1. So x minus 2 squared plus 1 equals to 0. There it is in vertex form. Now I'm going to go ahead and solve after I put it in vertex form. So I subtract the 1. We get x minus 2 squared equals to 0 minus 1, which is just -1. At that point, we're going to get rid of that squared. How do we take that square, get rid of it? We take the square root, or the 1/2 power, depending on what you like. Okay, and I'm going to write x minus 2 equals to the square root of -1, which is simply I. It's telling us we have an imaginary number, and it must be plus or minus because we're taking the square root. There's a positive, there's a negative. Now, let's get rid of that -2 with a positive 2. Okay. Once we have this, I'm going to rewrite it. X equals to 2 plus or minus I. If we want to write it in two separate ways, I could say x equals to 2 plus I and x equals to 2 minus I. Hope that helps you all understand finding the square root when we're talking the complex and imaginary roots, and how to determine what the roots are when they are imaginary and complex.